Welcome to our session, Hands-on Python, Coding plus Physical Computing with CodeSpace and Microbits. Glad you could join us here, and we're going to go through a few slides to get started. I want to make sure we give everybody a good setup, and then we're going to dive right into getting writing some code and getting familiar with the microbit. So hopefully you have your microbit ready, your kit from Firia Labs. I've got mine right here, already opened it up, my JumpStart kit, and it's got a whole bunch of microbits. I'm just going to grab one of those and then use the sensors from that as we go through the projects. So get your kit ready. Make sure you have access to a laptop. It can be a PC or a Mac or a Chromebook. It works great on Chromebooks as well. So that's all you need. We'll be plugging into the microbit with a USB connection, and I'll take you through everything you need to know. So whether you have any Python experience or any coding experience or not, you're going to have a good time. We're going to introduce you to all the little bits and pieces, and well, let's get started. So just a few slides here. Wanted to do an intro, talk a little bit about why we're doing physical computing. You know, what is that? We're not just coding on the screen, we're actually using devices, so that's important. And then how that relates to something in the tech world called IoT, the Internet of Things right now. So that's we're going to be delving into IoT a little bit as part of this workshop. And then, you know, why do we build CodeSpace the way we did? And then we're going to get hands-on. We're going to start actually writing some code. So get ready. So first, a little bit about me. We're based in Huntsville, Alabama. I've been an engineer here for a long time, more than 20 years, working everywhere from NASA to telecommunications companies, to various different startup companies. And the last startup company I worked at, and I helped start that company, was called Synapse Wireless, and we did Internet of Things devices. So little electronic devices that communicate from embedded applications, like in the middle of solar fields, out in solar farms, in remote locations that we need to collect data and get that up to the cloud so you can monitor what the performance is like and see if there's any issues and things like that. Even solar trackers that track the sun. Lighting applications. You think about lights as just being kind of old school, but with the revolution of LED lighting and then the ability to dim and control lights and have lights be really interactive to occupancy of a facility or sunlight coming through windows, they can automatically dim or brighten the lights based on how much ambient light is in the room. All kinds of great applications that really require a lot of different sensors and a lot of different controls that you might not have thought of, and it turns out there's software running in that stuff. So these are sorts of applications you can kind of see on the page here that you, as an engineer these days, a computer scientist or an electrical engineer or other engineering disciplines that work in these areas, you get to do a lot of things that you wouldn't ordinarily think of as sort of computer science-y things. So it's pretty cool kind of new wave of computing that's coming along. So we're also going to talk about Python. So how does Python relate to that? Well, Python is a programming language, and it's actually a very popular programming language. It's one of the most popular professional programming languages out there. And you might have heard of other languages like Java and C++, JavaScript, and they are also popular in different spheres, for different reasons. Each of these languages kind of have their sweet spot of where they're, highly applicable, and then sometimes there's a lot of crossover where you could use you could pick from a handful of languages to implement a particular type of application. But it turns out Python is really very useful and applicable in a lot of different areas. So it is a general purpose language. And one of the cool things about it is you can use it on the cloud for machine intelligence types applications, artificial intelligence or machine learning and those sorts of things, data science. But you can also use it on tiny little embedded devices. And that's what we're going to be doing today. We're going to use it on a little battery-powered device called the microbit. We're going to see how Python can help you actually control these physical things in the real world. And back to my experience, my background, we used Python and still do use Python on a lot of applications that are those IoT, Internet of Things applications, both in the embedded side of things, as well as on gateway devices that connect remote networks to the cloud, as well as on the cloud. So it's very, very useful. One of the things I like to tell kids when we're teaching them Python is, this is real stuff. You could get a job very easily writing Python once you get pretty good at it. And it's neat that a really great beginner's language, also happens to be a really great language out in the professional world too. So that's a cool aspect and something that really is appreciated by the students. So connecting with students, right? So a lot of times, different types of students, they're interested in different things, and a lot of them may not be or may not think they're interested in anything that has to do with computers. But one of the cool things about IoT, Internet of Things, and physical computing is these are computing applications that are embedded in all kinds of activities that are, in your life, in areas that you never thought about seeing computers. I got the football helmet here. There are applications for putting accelerometers and temperature sensors inside of football helmets, so you can see, the health of the player, how hot they're getting out on the field, impact, and things like that. So you can monitor that from the sidelines, kind of like monitoring race cars. Think about monitoring individuals and players. Dancers. We had actually an application a few years back where we outfitted a whole dance troupe with their tap shoes with little tiny microcontrollers with radios, similar to what you're going to be using with the microbit here, to be able to do a light show that went in time with their dancing. Movie effects, Tron 2. We actually did an application for Tron 2 back when that movie was being produced to light up the suits and control things that were done on the soundstage. Some of it's done through computer graphics, but a lot is still done through physical effects like that. So it's kind of a cool application. Music, obviously, there's been a lot of electronic music out there, and a lot of it now is software controlled. So that's a huge area if you're interested in music. There's some great, new ground being broken in making software assist for music production and instrumental music. Smart agriculture is another really neat one. There are lots of applications we've worked on, my company has worked on in the past, to do with monitoring livestock. Monitoring their health. I call it like a Fitbit for cows. If you think about being able to monitor a whole herd of cattle and know something about their health, inventory, real time, and all that stuff. And then, in growing crops, being able to do precision agriculture so that you know exactly what sort of pests are coming into the crop at this particular time. This is an application where you can do organic farming by using pheromones, and if you know precisely what sort of bug this is, you can dissuade it from infesting your crops by using some smart science there. So anyway, really cool applications. One of the things I like to say is to teachers is, no matter what a student is interested in, chances are there's going to be some innovations happening in that field over the next few years that have to do with computers and technology. And you can stand on the sidelines and watch that happen, or you can be a part of that change and you can shape it the way you want it to be. And I think this gives us an opportunity to get a broader range of students interested in computer science and technology. And also they should be. We need a broader range of students getting their perspectives and putting their perspectives into how these applications and how these technologies are going to roll out. Otherwise, you don't want, Mark Zuckerberg making all those decisions, right? You want to have your students, people that are really, that understand what the needs really are. They're going to make the best innovations. They're going to make that technology really work for, the world in a positive way. So we came at this Firia Labs to really try to bring something authentic to students. We wanted to demystify a lot of the technologies that are out there, and we also didn't want to sugarcoat it. We understand there's block-based approaches as opposed to like the text-based coding that professionals use, and that's great. The blocks are great for introducing the concepts to kids, but by the time they're in middle school and certainly in high school, they understand that, out in the real world, it's text-based code, and we believe they're ready for it. We're going to teach them real Python coding. We're going to take it one step at a time, and we're going to give them the tools to be able to successfully troubleshoot and debug their code. So that's part of that demystify aspect, is when their code doesn't work, and little secret here, it never works the first time, right? It's always, you've got bugs in your code when you first write it. So we need to give them the tools and the abilities to troubleshoot. So a lot of what we do is to teach that troubleshooting. And we just found that the tools that were out there that were being used in education, by and large, weren't providing that capability. They didn't give you a debugger that you could step through your code and really understand what was going on. And so that's what you're going to be using in CodeSpace. You're going to see how we can empower students to be willing and to take the risks and go out on their own and make their own code, make their own mistakes, and be able to fix those mistakes. So that's a key part of what we're doing. We actually got an NSF grant to develop the debugger part of this because it was a missing link, and so we really are proud of that feature of our technology. And we've been in a lot of classrooms, and we've seen it work. We've seen students of all kinds just dig into it, and all ages. It's really applicable. The microbit curriculum that we're going to talk about today really spans everything from, upper elementary ages like 4th, 5th, 6th grade, all the way through 12th grade. Easily is able to captivate students' attention. Learning programming is a lot like learning a language, a foreign language. So it's, you're going to learn the simple words first and the simple sentences. Whether you're an adult or whether you're a kid, you're learning the basics first, right? And so that's kind of the way we dealt with it in our curriculum. Is we're not dumbing things down. We're not making it oversimplified. We're not talking down to the students. So whether you're a 7th grader or a 12th grader, we're gonna treat you like a professional, right? And we're gonna take you through this in a serious way. But we're gonna build projects along the way. We're gonna make it meaningful. And so that's what you'll see as we go through the curriculum today. There are a lot of teaching resources that we've put together. So we, initially, I guess we started out as technologists entering the education space, and we built this great online tutorial style, platform that would take students through and teachers through and give all the scaffolding and supports that we felt like, would be needed to teach coding without having any prior background. And then we met a lot of teachers, and we realized what the real needs are in the classroom of actually doing, having rubrics and assessments and lesson plans and standards alignment and all those things that, make this really something that we can bring into the classroom in a broader scale. And so that's what you'll find if you go to our website, firialabs.com. There's tons of teaching resources, educator resources up there. We've got them all downloadable. Most of them are Google Docs that you can take and remix yourself. So go up to firialabs.com. You can see the tab Educator Resources, and you can take a look at what we've got there. It walks through all the pacing and sequencing and things like that for all the projects that we're going to go into today. And we're only going to get a taste of them, and we don't have that much time today. We're going to spend maybe an hour. I don't want to spend take too much of your time because it's hard to sit and watch something that long. But we'll get through a little bit of it just to give you a taste of it. I'll get you started, and then you can take off on your own. And definitely reach out to us. You can send an email to info@firialabs.com. We'll get right back to you if you have any questions or just any additional needs as you go through this. All right, so head over to make.firialabs.com in your browser. You will need a Chrome browser. We have technology that depends on something called WebUSB, which lets the JavaScript browser use your USB port directly to talk to a device. So make sure you're on Chrome and make.firialabs.com, and then click Sign In with Google. So you can use any Google account, but you do need a Google account to do this. So I'm just going to use my personal Gmail account. And starting from a brand new user account, so I've cleared out, deleted my account so that I can see this new user tour that comes up. You'll get a tour popping up right off the bat, which says "Welcome to CodeSpace." So we're going to start with the tour. It's basically going to give you an overview of what's in this environment. It's a programming environment, so it has a text editor on the left-hand side. It's got, on the top here, you'll see a place where you can select which curriculum you're using. So we're going to be using JumpStart Python today. So we're going to see that in just a little bit. We're going to enter in our license key there to activate JumpStart Python. So I'm going to go ahead and click Next. Over on the right-hand side of the screen, we've got our lesson panel. So this is where the tutorial style instructions are going to be that take the students step by step through each project. And they really do need to read over here. This is all of its good stuff, good juicy information. As you go through the projects, you'll earn experience points. So there's a little XP bar up there. And there's a progress bar that shows you how far you are through a particular project. So you'll see that continue to increase as you get towards the end of the project. You can always click on the project menu up here, and you can see the different projects ahead of you. And so that also lets you navigate backwards and forwards through projects. And up in the upper right-hand corner, there's what's called the Toolbox. So as you learn things and you'll see concepts along the way, you can click on these little tool marked words. So this has a little blue wrench next to it. And if you click on that, it goes into your toolbox. So I'm going to click debugging, and you see I've got one tool in my toolbox now. So now I can learn a little about debugging. This is a way that students can get a little more deep and thorough information on stuff that we may not have wanted to put inline in the code, but oftentimes we'll also use, or not the code, in the curriculum, in the instructions, but oftentimes we want to provide a little extra information that they can refer back to later, that's going to go into sort of a glossary. So the toolbox sort of acts as that glossary. So you can click, control flow, what's that? You can click on that, and now you're starting to learn some things about code, and you could continue to follow the links through the toolbox and gain more tools, but we'll kind of stop there, and we'll collect those tools as we go along. It just gives the students a way to build up that sort of repertoire of knowledge as they continue. And finally, at the end of every lesson, every step of every lesson, there's a next button down towards the bottom of the screen. And so we'll always want to make sure you scroll down, see all the content, and click next. Sometimes there's actually a task that you need to do, like type in the code, and CodeSpace will validate that you've really executed that code before it'll allow you to continue. And so you need to do that so that you get each step checked off on the list, because we are keeping track, so that as a teacher, you can use our teacher's dashboard to see if your students have completed all those steps and that sort of thing. All right. Next thing we're going to need to do before we go any farther is let's make sure we get an activated license. As you can see right now, I'm on the free trial. So I'm in a free trial with microbits. So there's one of those for CodeBot as well. But what we want to be is on the JumpStart Python. But right now I don't have any seats available for JumpStart Python, so I need to enter in a license. And I can do that one of two different ways. As a student, I'm just going to enter a share token. A share token can be generated by anyone that has a license key installed. So as a teacher, when you've gotten a JumpStart kit, you will have a license key that will be emailed to you along with that. So if you have that, you can go over to Manage Licenses and then Add License here, and it'll add, and you'll see your list of keys once you add that. So you actually, the easiest thing to do is paste in the license key. It's just a string of letters and numbers, but paste it in from the email, and then you can activate it there. But what we're going to do instead, I'm going to go click here again, and so back to this curriculum module selection. We're going to pretend like we're students. Okay, so it's what a student would typically do once a teacher's generated a license, or I'm sorry, has added a license in this Manage Licenses, they'll be able to generate a share token. And a share token is just a two-word phrase that will be random 2 words. So the one that I generated earlier is insofar goosier. And believe it or not, I guess those are words. I'm going to click Validate. And so now I have lots of seats. I've got 99 seats, or 100 seats available. One's already being used on JumpStart, and 100 seats of Python with robots. So that's my training license share token. So go ahead and enter that in if you want to for the purposes of this workshop. And then, but after that, put your own license share token in there, your own license key and your own share token in there. If you want more information on that, if you go to our FiriaLabs.com webpage and look at the resources, we've got additional help on how to deal with licenses and share tokens. The good news is once you've done it and entered it in, like as a student, once I've entered that share token, activated the course, it's going to remember it the next time I pop into CodeSpace. When I log in, I'm going to be right back where I left off. So you don't ever have to do it again. So you can always go back and look if you want to and say, oh yeah, I'm on active as JumpStart Python, and that's cool. So everything's there. So, and you can also tell you're on, you can see it doesn't say free trial anymore. And I've got lots of projects here. The free trial only has the first 2 projects. So that being said, we've already taken our tour. So we're going to click next. And you see when I click next, I got a little bit of experience points there. So my XP is up to 30. If I go back, I can always go with the previous step, or I can advance to the next step. If I go back, you can see I've got a little green check mark here. That means I've completed that step. So that's great. If I advance forward, I can see I'm on this page that tells me a little bit about sort of the legend of what the symbols as we go through the tutorials are going to mean. And so that's good. I've read through that. What if instead of clicking next, I just use the advance button? So if I do that, you notice I didn't get any XP for completing that step. But if I go back, I see I don't get a green check mark next to it. Whereas if I scroll down and click next, I did get some XP for completing that step. And if I go back, those first 2 projects have been, our first 2 steps have been completed. Okay, that just gives you an idea of how we check for completion and how you can look at your, over your student's shoulder and see that they've completed that. But also on the teacher dashboard, you'll be able to look at that and see where all your students are, what steps they've completed, and that sort of thing. So to start out with, we're going to talk about the microbit. So I actually have a microbit here, which you will get in your JumpStart kit. And this sort of talks about what is the microbit. It's actually got a little embedded computer on it that you can use it to connect into a lot of different types of applications. So it is a physical computing device. We warn the students, like all electronic devices, it's susceptible to static electricity. So don't charge yourself up and shock it. We have not found these to be really very delicate. They're pretty rugged and dependable, but just in case, it's always a good idea, especially in the wintertime when things are very staticky, to discharge your static if you can on a doorknob or a light switch or something before you start playing with electronics. So here we go, the quiz, the first of our formative assessments that we present to the students along the way. What should you do before handling a microbit? Well, if I read this carefully, I would know that it's probably not jumping jacks. I lose a little bit of XP for guessing wrong. It's touch some grounded metal. Yay, I got that right. All right, cool. So on to the next step. This is the point where we normally would hand out the microbits to the students and let them actually start looking at them, because we want them to physically touch it and see the chip. So you can actually see the parts on the board, and that's really important. We want the students to get a connection that this is real stuff. You can point out that these exact same types of chips are inside your cell phone, inside all the things that you use in your life. So like specifically the accelerometer, it's the thing that tells a game controller or a cell phone whether it's in portrait or landscape mode and that sort of thing. And you're going to learn through the projects how to control that accelerometer with code, how to read it, how to react to it, and change the user interface based on that. The computer, the CPU, central processing unit that runs your code, is right there. It's that little guy right there. So pretty cool to be able to look at these things and kind of get a feel for what those pieces of electronics, those microchips, actually look like. The other side of the microbit has an LED display. So you've got a 5x5 matrix of LEDs there and a couple of push buttons that we're going to be using. And then there's an edge connector. Those little gold tabs there are actually electrical connections that we're going to hook up alligator clips to later and actually make them do things. So make sure you explore and take some time to get to know your microbit. So without further ado, though, we're going to connect this little guy using a USB cable. So this is a micro USB cable that comes with the kit. We're going to plug it in. Micro USB only goes one direction, which is usually the second or third direction that you try it in. But once I plug it in, you'll probably see a pop-up on your computer. I've already plugged this one into mine and it remembered it, so it automatically said it was connected. Yours, it will pop something up. So if you see a little dialog box pop up on Chrome and says make.code or make.firialabs.com wants to connect is what it'll say. And then it'll either be named CodeBot Pi REPL or LPC 1768. There'll be a little name of a device. Click on that device and then click connect. And that should allow you to see that USB connection turn from gray to black, which means it's connected. So once you've done that, you can continue on. And the next thing we're going to do is name our first program. So up here in the upper left-hand corner is the name of the document you're working in. And we kind of modeled this on Google Docs because a lot of students are somewhat familiar with how that works. And a little bit of foreshadowing here, we're naming our first program Heart1. So it's going to have something to do with a heart. So let's go ahead and do that. Heart1. Okay. You can always click up here and rename it again if you want to name it something different. So now that I've done that, so our first program, show some heart. Before we start coding, remember you've got to type in exactly the right syntax, and that's something we're going to learn along the way. And it's okay if you make some mistakes, but we want to point out, punctuation is important, and capitalization is important. But just in case students miss it and they don't read, sometimes they don't read, let's just give it a try. All right, I'm going to get over here on this editor panel on the left, from microbit, import star. And then the next line of code is display.show, dot is like a period, show parentheses, image.heart. Okay. I've typed it in, looks just like that. Show me how to run the code. Absolutely. Okay, there's a little run button. It looks like play on a CD player, cassette player. I don't know. It's play button. And that actually is going to send the code across the USB cable into the microbit. So your code is actually not going to run on your computer. It's going to run on this little chip right here. So once it's running, you could unplug the microbit, put it on the battery pack, and go to town because it's actually programmed onto the chip. So let's give that a try. Oh, stop. There's also a stop button. So if your microbit happens to be already running code, you can click stop. But it should be ready to run right now. So I'm going to click run. Run. Oh, wait. Okay, I need to be connected here. All right, it wasn't. Okay, so now I'm going to hit run. And, what? Runtime error line 1. Oh, this is good. This is good. It puts us right on the line of code where the error happened. So what's my error? It says no module named microbot. So not knowing anything about Python, let's say, I'm looking at this going, microbot. It should be microbot. No, it's microbit. Oh, I thought it was bot, but I'll change that. All right, so I'm going to fix that. I'm ready to see a heart on here. I think that's what's going to happen. Go. No. Check capitalization of show. If I clear it, it shows it again there. Check capitalization of show. Well, looks good to me. Oh, wait. No. It's supposed to be all lowercase. That was nice of it to tell me that. Okay, run again. Check capitalization of heart. Okay, heart has to be all uppercase. So picky. All right, let's give that a try now. And go. Wow, I have a heart. Who said I didn't have a heart? Look, there it is right there. Perfect. Okay, so I've got my first program running on the microbit. 2 lines of code, wasn't too hard. Python, made me struggle a little bit because it's pretty picky about the capitalization and things like that. But CodeSpace was nice enough to tell me exactly where the errors were, so that's good. So, do you see a heart image on the microbit LED display? Yes! Sweet! All right, let's proceed on. So the microbit has a lot of built-in images. Like heart is just the tip of the iceberg. Let's click on that tool and get something else in our toolbox. So there's lots of them that we can try. So really the next thing is, let's have our students just play around. Let's try some different, images on here. A lot of these, I don't even know what these things do. Let's try rabbit. I wonder what rabbit looks like. So image.rabbit. Okay, kind of looks like a shadow puppety rabbit. So play around a little bit. You can also look at some of these other tools. What about these underscores? Okay, it's a way to make code more readable. Different languages have different sort of conventions, style conventions about how they do it. So we're trying to show you the traditional Python style of doing underscores to separate names like this. And yeah, so modify your code, try to do some different images. And usually you'll see a couple of things I want to show you. You'll see hints along the way. Sometimes we collapse them. Sometimes we blur out part of the part of the solution so that the students can use their memory a little bit and try to figure it out before they look at the full solution. But generally in JumpStart Python, we'll give you along the way, we'll give you most of the solution so you'll be able to get it done. So try a few different images. One other thing I was going to show you is the toolbox itself. So if you click on this toolbox, I can actually see the tools that I've discovered so far. So this gives you a little bit of incentive to go ahead and click on those tools when you see them. So if I ever want to go back later on, or let's say I'm coding on my own, just I'm playing around here and I'm in a different project, but I want to add some new images, I can always go back to my toolbox and look back at what those images are, or look back at different concepts that I've learned about in the past. So that's a really good feature to have in there. If you're, once you get your sea legs in coding, you'll be able to turn off the lesson panel and just use this as a development environment. Use it as an editor and a development environment and a debugger for the microbit. But you can always pop the lessons back on, use the toolbox as a reference. But we're going to go back to the projects. So we've tried a few different images. All right, click next. We've completed our first project. That was it. Pretty simple. A journey of 1,000 miles begins with a single step, and we've taken it. So congratulations. So if you were using Google Classroom, as a teacher, you can sign into your CodeSpace account and you can actually upload, I think it's under the help menu here, you can add student assignments. So you can pick a Google Classroom that you teach, and then it will upload all the CodeSpace JumpStart assignments to that classroom. And then once you've done that, your students will be able to click Turn In. And so any classes that they're enrolled with, they can, they're enrolled in, they can click and turn into that class. So that's a little Google integration in case you're using Google Classroom. That is a separate concept than our teacher dashboard. So if you want to do the thing that I was mentioning earlier about kind of keeping track of the progress of all your students through all the materials, that's in our teacher dashboard here. So it's really a completely separate thing, but students can also opt into your class, and then you'll be able to monitor all of their progress and things like that in Classroom. So, very good. Let's go to the next step. All right, on to project 2, display games. So this is the project where we're going to really get to know that LED display a little bit more, but also do some things with the push buttons and learn a little bit more Python code. So, displays are everywhere. Car dashboards, scoreboards at a football game. We're gonna get into that. So the project goals are to show a sequence of images. So we're gonna try to do a little bit of animation on the display, maybe even scroll some text messages across the display, right? And see if the microbit can be used to display numbers, do a little calculation. And then we'll get into gaming just a bit with a push button fast click game. So to start out with, we're going to use some code very similar to what we just had written. So all we have to do is change the image dot heart or whatever you have up here into an image dot square, and we'll be right on track. So I'm just going to double click there and change it up. So here we're going to talk a little bit, we're going to give a little bit more explanation about what this is doing, right? So what is this from microbit import star all about? Well, that first line, it's an import statement. So an import statement is a way to reference library modules. So it's other chunks of Python code that are resident on your chip, on your microbit already, that you can refer to and say, hey, my code wants to use this microbit module. And now I can do things like use display and use image and other things that are part of the microbit. So that's code that someone else has written that's been put into the microbit that your Python code can access. Those are called libraries. And in Python, they're called library modules. So you can bring in different types of modules. Like we'll be talking about a music module next. So you can play music on your microbit, or a random module. So you can create random numbers. So we can read a lot more about imports, but for right now, let's press on. So let's try running the program. Actually, let's try not. It makes me run the program. Okay, let's run the program and see what's happening here. So run. Okay, I get a square. Nice. Yes, I see a square. Okay, now let's try to do 2 images in a row. I want to see them kind of animate, right? So the computer's going to execute code sequentially. So like first it did from microbit import star, then it did display.show image.square. Now let's make it display.show image.happy. So we'll do square and then happy. Display.show image dot all caps happy. All right, let's try this. I can't wait to see them both go in sequence. That's going to be great. Square, then happy. Wait, it just displayed happy. I mean, it totally skipped square. I don't get it. Is it jumping over square? Let's continue on. We had a little warning here. Something is not going to happen the way we think. So what do you expect the code above to do? Display each image quickly and end showing the last one. Maybe. Display only the first image or show the images for about 1 second each. Well, there's no reason why it would take a second. We never said 1 second. So I guess it's display them quickly and then end showing the last one, which maybe that's what happened. Yeah, that must be what happened. All right, so this didn't work the way we planned. That's part of the joy of coding, right? It's not going to work the way you think the first time. So we tried the new code. It doesn't really work the way we want. We're never seeing square at all. We're only seeing the last thing we told it to do. So why is that happening? The display, and this is the display tool, right? Now we know about the display, and there's all kinds of functions that display can do. Ooh, scroll. You can scroll text. More foreshadowing, right? So those are all things in the display object inside the microbit module. So it stays active though, even after our program runs really fast. It displays square, displays happy, and it ends. In fact, when we run it, you'll see it says program ended. So it's done, but the display is still showing the last thing that we told it to do. So it's kind of running, it's just sitting there independently of my code. So both of the images are being displayed theoretically, but the square is probably really fast, really too fast to see. Well, just to prove that, let's see if we can see anything on there. Let's kind of like do a little more experimentation here. Square and happy is what we've got now. Let's add house and asleep. Notice how this blurs out when I move away from it. That's just showing me the parts that I need to type in. And by the way, you can copy if you select and hit Control-C and Control-V, or you can use your mouse to right-click if you want. So I'm just going to do a little copy and then change that to house. And change that to sleep. All right, let's see what those look like if I hit run. Huh, just asleep. I mean, I don't see the thing even flicker. The other images. It's just going straight to asleep. So if it's displaying those, it's going really fast. Okay. Yep, it ended quickly and the display shows the last thing, which is asleep. Ah, sure. As a robot, Cody here saw all of those images. We'll see about that. So, step by step, let's see with the debugger if we can really prove that the computer really is displaying all those images. So, we're going to try stepping through this code. And here you see a little video where we're showing what happens when you hit the step button. It actually starts at the top of your code. And the red outline is the code that's about to run. And it's about to run, and then when you hit step, it runs that line of code that's outlined in red. So that's what happens every time you hit step. The first time you hit step, it loads the code, and then next time it runs one line at a time, your code, and sits there waiting to run the next line. Okay, that's what we're thinking. All right, so how do you do that again? Press the step button. It's going to load the code on there. It's going to wait with the red box around the code, and then when you press the step button again, it's going to run that line of code and stop on the next one. So that red outline is kind of like a stop sign around that line of code. Let's just see. All right, hit go. All right, so it's waiting. It hasn't done anything. The display is blank. It hasn't run any code at all yet. So if I hit step, poof, well, it still doesn't show anything, because from microbit import star, that is a line of code that the microbit ran that code. But all it did was go locate the microbit module so that my code can now use it. So now I can use display.show, but I haven't called that function yet. I haven't done that yet. So let's hit step again. Step. It's the square. It worked. It displayed the square. So awesome. Now click step again. Happy, house, asleep, and my program ended. So one step at a time, I could see that the microbit really is doing what I told it to do. Python is running through my code one step at a time. And that's really key. That's a really key point about how programs work. They execute one instruction at a time, one line of code at a time oftentimes. So we can always slow down, step through, and see what the code is doing, even when it's not doing what you think it should be doing. All right, so we can always do that. Good. So we don't want to have to always step through it just to run it. What we want to do some animation. So how can we make it where it slows down a bit, even when we're not stepping? Well, there's a function called sleep. And so that's part of the microbit module is sleep. And sleep takes a parameter called milliseconds, which is thousandths of a second. So if we do a sleep 1000, that will delay for 1000 milliseconds, which is 1 second. Okay, that should be plenty of time. So now after each one of those display.shows, I just need to put a sleep 1000. And that will slow this way down in theory. All right, I'm going to copy that line, paste it in. Okay, I don't need one after the last one because it's going to end. My program's going to end and it's going to be showing that anyway. So let's see what happens if I run this. I'm just going to hit run. Oh yeah, nice, nice. It displayed each of them for 1 second and then ended. Sweet. Yes. Steady as she goes. Well, I've got this number 1000 all scattered through my code. In software, we call that a magic number. You shouldn't have magic numbers strewn all around your code. Nobody knows what 1000 is. There's a thing called a variable. And that's basically a way to attach a name to an object or something like a number. So if I say, I want to call that, instead of 1000, I want to call it the name delay. Okay, that would be a variable. Let's click on that tool. We want to get that variable tool. A variable is like a box with a label on it that you can put stuff in. Yeah, so I've got this box called delay, and I'm going to put the number 1000 in that box. Sweet. So, naming. You have to name variables with a letter or underscore. It has to start with a letter or an underscore, and then it can contain letters, numbers, and underscores. So just a little bit of rules there. So let's make a variable, and we'll just put it, here's our instructions here. We'll put it at the top of our code right after the import. So we'll say delay equals 1000. Now, everywhere where we have 1000, we can just replace it with delay. So now, if I run the code, it does the exact same thing that it did before. But now it's got this really awesome delay up in here. Now I could do something like change that number. Like I could make it go really fast. Like what if I want to go 500 milliseconds, so twice as fast? Yeah, or 100 milliseconds, really fast. Yeah, I got to do that again. That's awesome. Okay, that works. Yeah, I knew how to do it. A few different values. Yes, our variable is working. Variable is great. I've got it in my toolbox. Check it out. Variables. Now I know about variables. Awesome. Okay, little assessment time here. Let's make sure we're up to speed. We've been typing from microbit import star. What does that do? Now this is testing the students' knowledge. Did they actually slow down and read that tool? They might have to go back and get the import tool if they didn't, but we know we got it and we read it. The from microbit import star does not turn on the LEDs, does not import asterisks from the land of microbit. It provides access to the built-in microbit code. Yes. We added a variable called delay to our program. What does delay equals 1000 do? Remember when we put that up there? What does it do? Does it delay for 1000 milliseconds? No. Sleep does that. When we call sleep, it delays for however long we tell it to, right? So delay equals 1000 assigns the value of 1000 to a variable named delay. It creates a new variable and just assigns a number to it. Okay, cool. On with the project. Ooh, now it's getting really exciting. We're going to make text messages. Yeah, without our phones too. Okay, so we've seen lots of images, but how about words? How about text? So let's just try that with display.show. Maybe it can, I mean, we already know how to do display.show. Maybe we can just tell it to do text. So we're going to need to know about something called data types. Types, ooh, stir, int, float, and friends. Yikes. What is this data thing you speak of? It's just numbers or text, which are also called strings. Even that image type we've been using, that was a type. You know, it's a special type that was invented by the microbit module. Okay, so we know how to do that. So hello or something like that is a string. You have to put it in quotation marks. So let's try. We'll just erase the code that we've got, and we'll type. We'll leave from microbit import star. We need that. We'll go display.show, and then just a word. Ahoy! We're using ahoy because there's different letters in each of the word's letters. So here we go. Go. A-H-O-Y. Yes. Let's try that again. It actually worked. So it does. Display.show works great on text, on strings. Sweet. A string is just the thing. Love it. It shows the string one character at a time, which is cool, but it's kind of hard to read it that way. So let's try, because like check this out. What if I said instead of ahoy, hello? This will tell you why we didn't do that, because the L is up there twice, but you can't really tell it. It just looks like it's up there longer. So, it's not great. So let's try using the word scroll. Back in that, when we looked at the display, and we did that little bit of foreshadowing because we found the whole microbit module documentation for the display object, we saw that there was a thing called scroll, that you can give it a string. So that's what we need to do. Let's try that. Display.scroll. Oops, scroll. Hello, let's see what happens. Oh, that's very nice. Very nice, much nicer. Okay, so play around with some messages of your choice, like hello, folks. Oop, exclamation point. How about that? Oh, yeah. Nice. Okay. Yes, the display scrolled my message. Scrolling text is a lot easier to read. Okay, so now we're going to do a little bit of different approach here. We're going to use numbers, not strings. We're going to try to display.scroll a number. We're going to see if the microbit can be a microcalculator. So in this case, I'm going to say num, and this is just a variable. I could call it anything I want to. But I'm going to say num equals 2 plus 2. All right, well, see if Python ought to be able to calculate that. So now let's just display.scroll the num. And I'm expecting to see 4 scroll right by my screen. Go. Show me 4 is not showing. Ooh, I got an error. Type error. Can't convert int object to stir implicitly. So CodeSpace has helped me out here. It says type error. Don't worry, this type error message is expected. Your code is not complete yet. Continue the lesson to learn how to resolve this error. So this is where the curriculum kind of hooks into the debugger in CodeSpace, and we can intercept those error messages and say, hey, it's okay, young pupil. We intended to give you this error so that you would learn a little bit about data types. So what are we going to do? What are we going to do? We gave it a number. It wants a string. So it turns out there's a way to fix that. We can convert between different types. So there's a function called stir that converts a number, like an integer, into a string. And you can go the other way around too. You can have a string and convert it to an integer. So you can use int to do that. So we need this stir thing. We need to convert an integer to a string. If we look at string, at the help for that type, it actually tells us this information. And there's some more features of strings that we might want to use later, and we will use later in the course. All right, let's try this then. Instead of display.scroll num, we want to display.scroll and then stir num, which means we're going to make it into a string. You don't have to put a space here, but I find it's a little easier to read. We have to put the right number of parentheses. Notice I've got the matching, the parentheses around the num for stir. And these are called functions. We're making function calls here. We'll learn how to define our own functions later. But when you call a function like scroll, you have to put the parameters or the arguments to the function in parentheses. And the same with stir here. So that's why it looks a little strange. You've got nested parentheses there. All right, let's give that a try. Ah, yes, it calculated my 2 plus 2 and displayed the results. Nice. Yes, it is. That's a microcalculator. And, you know, you'll know if you get students that are math oriented because you'll see them doing crazy things. Like, can I do 2 times 12? Let's try that. Does it know that? Yes, it does. It does. So you can do all kinds of really cool math. And there's basically a built-in scientific calculator inside this thing. So there's lots of fun we can have with that. So the final thing we're going to do in display games is we're going to do a countdown, and then we're going to make our own game that uses the push buttons. So there's a few different bits of Python we're going to have to learn to get there. So let's get into it. So we're going to make a new file, and we're going to call it display game. Okay. Now, we'll start with from microbit import star. And the instructions are, we want to do a 3, 2, 1 countdown. So we want to make a sequence of strings, 3, 2, 1. And we want, maybe we'll display them for a second each. Well, this is the example, is just do 3 to start out with. So let's do it. Display. Notice we're doing display.show, so we can, so the number shows up all at once and doesn't scroll across the screen. So we're going to show 3, and we're going to sleep for a second. Okay. And then we're just going to do 2, 1, and copy that. All right, 3, 2, 1. All right, so there's our countdown. 3, 2, 1. Okay, let's just see if we get that far. All right, 3, 2, 1. All right, I hope you've got a countdown. This is getting exciting. Ready for liftoff. All right, next, we want to be able to monitor button presses. So while the countdown's happening, the way this game works, the user is supposed to click, 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 click as fast as they can. And when the countdown ends, we'll find out how many times were they able to click the button. It's one of those rage games, you know. So click it as fast as you can. All right, so we're going to use, we can use button A or B. So there's a whole buttons documentation here. We picked up the buttons tool, and we can say, was it pressed since the last time I asked? Or is it currently being pressed? Or how many times was it pressed since the last time I asked? Those are kind of the 3 functions in the interface for buttons. So we're going to button this thing up. In our code, we're going to just add to the end. We're going to get the number of button presses. We're going to store that in a variable called x, and then we're going to display.scroll that number so we can see how many times they pressed it. Notice how the code is kind of collapsed in here. If I click in there, it'll show the whole program. So, and then it'll blur out what I don't need. So right now I need those 2 lines of code. So x equals button underscore A. So we're just going to check button A this time. Get presses. So that gets the number of presses since the last time we asked for the number of presses, which was never. So it should be the number of presses since the beginning of the program when it started running. So then once we've gotten the number of presses, we're going to display.scroll x. Right? Okay, let's do it. Press button A. Go. 2, 3, 4, 5, 6. What? Can't convert int object to stir implicitly. Oh, wait a second. I was supposed to say stir x. That was that one again. That same, I should know that. That same little bug. Okay, let's try that again. I'm going to press it. I'm going to tell you how many times I'm pressing it. We'll see if it counts properly. 1, 2, 3, 4, 5, 6, 7, 8. And it says 8. It displayed 8. It only scrolled at 1 time. We can fix that later. All right, so can we get 10 clicks? More than 10 clicks? Let's see. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 12. I got 12. Awesome. So 10 clicks is good. Yes, we're counting our clicks. We got gameplay going on. All right, for the win. So back on the first page of this game challenge, we said that, the winner would get some sort of prize. Like if you win, you'll get a t-shirt. So we're going to display.show image.t-shirt. If you got more than 9, means you get 10 or more clicks. All right, so we need to do something like this. If the number of clicks is greater than 9, then you display a t-shirt. Otherwise, it will just display how many times you clicked it. So in Python, you can use an if statement. So it's a conditional statement, if, and then you put a condition in there. So if x greater than 9, and you have to put colon after that condition, which every time you see a colon in Python, that means there's a new block of code coming. And so you tab in Python, you hit the tab key. You can just use spaces if you want, but we really recommend you use the tab key because you need to be consistent with the number of spaces when you indent. So indentation is very important in Python. When you code that's indented at that same level will be in that same block of code, for instance, underneath this if statement here. So for right now, display.show image.t-shirt goes under the if x is greater than 9. Then else means if that condition is not true, then we're going to do this. We're going to display.scroll stir x. Watch that indentation. You see how it's all lined up there? Okay, and that's called branching as well. So we're going to take a different branch based on a condition. If x is one way, we're going to go this way, or x is not, we're going to go that way. So those conditions can be a lot of different things, like less than and greater than, and others, and we'll talk about that later. That, again, the indentation is super important, and we have lots of examples of those sorts of if statements. So let's do this. It's time to type in the code. All right, down at the bottom, after our get presses, all right, then we'll check. By the way, we can put as many spaces as we want. White space is ignored by Python, so it's okay. All right, so after we get the number of presses, let's do an if. If x is greater than 9, colon. When I hit the colon, it automatically, and I hit enter, it automatically tabs out there because after a colon, there's always going to be an indentation. All right, so display.show image.t-shirt. All right. Now, else, colon. In this case, I'm just going to tab to make that display.scroll in my else. Okay, so now let's see what happens. If I hit go, and then I click it a few times. I only clicked it 5 times. I lost. All right, let's try going faster. All right, run, 3, 2, 1. I got a t-shirt. Yay, I must have gotten 10 or more. All right, awesome. So you could obviously make the game harder by increasing the number there, or you could add other features to this game. And as we learn new things to do with the microbit, this would be a great one to come back and add features too. So it's just a really basic reading input, displaying some output kind of program. Yes, I can win the t-shirt. Nice. It's our first micro arcade. All right, this is a good time to point out to students that, hey, let's take this on the road. Let's unplug the microbit. You can grab a battery pack, which comes in the kit, plug it in. The battery pack has an on-off switch. I will say be careful when you plug the battery pack in this way on the little white connector there. It goes only one direction, so you make sure you're turning it the right direction. And then when you unplug it, be careful to pull on the plastic housing, not the wires. So it's a little bit tricky there. Sometimes if you don't have fingernails, it's hard to get that pulled out. Actually, if you look on our website, we have a Thingiverse account where we've got a 3D printable connector puller for the microbit. So it's really handy there that you can print out and make it a lot easier to pull this connector out. It's that hard, but well, if you don't have fingernails, it is that hard. Okay, so that's pointed out here. When you reset, you can reset the microbit by pushing this little reboot button on the back. So since your program, it doesn't run in a loop, it only runs once. you're going to want to click reset to play the game again. So that's how that works. So even though this was simple display kind of stuff, it actually represents a lot of real world applications. Counting the number of times a car passes through an intersection, or displaying these LED displayed traffic signals and things like that. That's all real world stuff. And so you're learning some bits of code that you're going to be able to integrate in a lot of real world applications. So nice job. Next one, we're going to hook up a peripheral. Get ready. All right, now it's time for the next project, Micro Musician. All right, this one is combining computers and music, one of my favorite things. Computers and music go great together. A lot of times our students are exposed to this and don't even realize that a lot of the music that they're listening to and the artists that they follow are using a lot of software. And it's good to be now giving them a chance to be not just users or consumers of that technology, but creators of it. So let's see what we can do here. With the microbit, we've already talked about it has an edge connector. Those little metal stripes on the edges, we can actually connect to external peripherals. So in this case, we're going to connect a speaker. So let's do it. You'll notice in your kit, there's a peripheral pack that comes with it. There's actually lots of alligator clips and things like that in the kit. And I'm going to take 2 of these alligator clips I've pulled out, and I've got my speaker here. It's a little black cylinder. If yours has a little sticky cover over it, take that off, just peel that off and throw that part away, because the sound's not going to get out very well without uncovering the sound hole of the speaker. Then you'll need to take these 2 alligator clips, and you can see that it's showing a nice little picture in our lesson about connecting the clips, 1 to each pin of the speaker. Okay. And then the other ends of the alligator clips, and obviously it doesn't matter which color alligator clips you get. I guess that's obvious. Clip onto the ground and the pin 0 of the microbit. So you can see it probably more clearly in the picture than on my screen, but there we go. Now I'm hooked up. Okay, so make sure you keep the alligator clips straight so they don't cross over and short multiple pins together. That can make things not work right. And once it's connected, let's create a new file. So we'll go File, New. We'll make a file called Music1. All right, and in this case, we're going to just import the music library. We're not doing the microbit library this time. Music is its own separate library. And then there's a function in here called music.play. And there's also a library of songs. We're going to play one called Nyan. Wonder what that is. All right, let's try. Hold it next to my mic here. Aha. It's meme-alicious. All right, so the code is very simple. It's just as simple as doing the display.show. So this is just a way to use a built-in library to play some music. There's, in a later lesson, we talk about how to create your own tunes, create your own, completely control the frequency and duration of sounds coming through the microbit speaker. So it gets a lot more involved than this, but we can play around. We talk about a little bit, we've already talked about the import capability, that we can import multiple modules. So this is another example of that. So in this case, yes, we've got some sound going. Awesome. So next, you're going to want to play around, just as you did with images. You're going to want to play around with some different songs. So the microbit has a whole collection of different tunes built in. And as we mentioned, there are ways to create your own tunes and create your own just frequencies in general. But to start with, try playing some other tunes in here. Another thing that you can do is, even though we didn't the first go around, you can bring in the microbit library itself, and then you can use sleep delays, and you can use the display and things like that. So in this case, let's bring in from microbit import star and display something while we're playing music. So we'll just put this right here, from microbit import star. It really doesn't matter what order your imports come in. And again, blank lines are acceptable to sort of organize your code a little bit. Display.show image dot all caps music quavers. You might have seen this lurking around that image library and wondered, what is what are quavers? What's this music quavers thing? Well, the microbit comes from England, so they put some terms in there that are English terms. So this must be an English musical term. Let's find out what that is. So let's go. Oh, let's do a different music. Let's do a different song too. Let's try Python. What could Python be? Music.python. Okay, different song, and now we're going to put quavers with it. Nice song. And quavers are eighth notes. Who knew? All right, excellent. So play around with some different songs. We've got that going. It's really nice. This was a really simple, short project just to get you accustomed to actually connecting up things to the microbit. And from there, it proceeds to more advanced and interesting topics. Thanks for attending our session. Definitely feel free to reach out. info@firialabs.com is your friend. And we'd love to chat with you about your thoughts on using the microbit in your classroom. And we have lots of resources to help you. So, we're looking forward to getting to know you a little bit better and chatting more. Thanks.